Okay, well, welcome to the early afternoon session on edge computing and energy and utilities. So we're going to focus on talking about the different use cases, the business benefits, the challenges involved in deploying edge technology, and why it's important in the overall enablement of business outcomes within key use cases in the energy and utilities sector. And also why in some cases it might actually be critical to even be able to sell a proposition of an IoT-enabled solution to your stakeholders or to the business. A little bit about myself. I'm Jesse DeMesa. I'm a principal partner with Momenta Partners. Momenta Partners is hyper-focused on connected industry. We deliver growth acceleration services to large industrial companies, enterprise infrastructure providers, enterprise application suppliers, and also early stage tech companies in the IoT or connected industry space, and basically work across the ecosystem to basically drive the acceleration and innovation with partners and with large industrial suppliers, enterprise companies, to really start delivering value from IoT-enabled solutions and business outcomes. A little bit about my background. Before being with Momenta Partners, I was with GE Oil and Gas as CTO in digital and in GE Oil and Gas for 3 years, and with Siemens as a CTO in the energy, oil and gas division and in the industrial automation division. Little bit more on Momenta. We basically drive growth through 4 integrated practices around investments in early stage companies, advisory, executive search, and also merger and acquisition support as well. So a little bit on the panel, we're going to talk about, as I mentioned, basically the drivers behind edge computing and the industrial internet and why it's important. But before we get started, a show of hands, how many think edge computing is important to your overall IoT strategy and delivering business value? That's great. That's almost 75, 80%. How many do you actually have programs in place or you're supporting programs where edge is a part of that initiative today? Okay, maybe half of the people that raise their hands. So I think this will be an illuminating session. I'll go ahead and let the panelists introduce themselves and we'll get started. Thank you. Good, Russ?
My name is Russ Henn. I'm with HCL Technologies IoT Works business unit. My background is 25 years in consulting with utilities, mostly in North America, and the last 12 years or so focused on smart meters and smart grids. So I look forward to talking about this topic with you today, and stop by HCL's booth if you get a chance during the show.
Thank you, Russ. My name is Olivier Frank, and I'm heading worldwide sales for Hewlett Packard Enterprise Edgeline business. So we'll talk about it. We're very focused on the edge. And my background, I have 20 years of more the IT experience and consumer electronics. Today we're engaged into pursuits into energy and utility via oil and gas, via electricity companies. And so obviously be happy to share some of our learnings.
Okay, my name is Teresa Tung. I'm a managing director at Accenture Labs, which is the research arm of Accenture and our clients. And I lead the work around Internet of Things, big data, robotics. And I'm here to share some of the work that we've been doing, not just with edge computing, but with edge analytics and about bringing analytics to the data.
Great. My name is AJ Gupta. I'm with Huawei Technologies. I've been there for 6 years, responsible for some of the marketing of the network product line solutions. I have been associated with various initiatives at Huawei. Like, as you might know, Huawei is the founding member of the Edge Computing Consortium last year, and we also launched our umbrella, so-called ECIoT on edge computing and IoT. So I've been kind of working with the team on some of those initiatives, actually. Kind of just quickly, one more point here. Years ago, one of my early jobs was actually I was posted on a Schlumberger oil rig on the drilling floor, and we were at that time trying to make sense out of the drilling data, and we have this thing called IBM PC, which was really the big thing at that time, if you can imagine. So it's like a deja vu all over again. Looks like we have come a full circle with edge computing.
All right, well, thank you. Well, to get started, let's actually start with different perspectives and definition of the edge. I don't think in the industry today we really have a standard definition. So I'd really like to get some different perspectives on how each of the panelists and their companies define edge. And so to do that, let's start with Olivier. Could you define edge for us?
Yes, so for us, edge is everything that is not cloud or data center, basically everything outside. Now, there are different types of edges. Obviously, today we will focus around industrial IoT edges, but the work we're doing a lot of IT edges like campuses, branches in enterprises. We're spending a very significant amount of time on telco edges, so the whole 5G, mobile edge compute, see-around initiatives that are very triggered by what we're doing. And then, of course, the IoT edges, where, we're basically starting with the things, and the things can be human, can be assets in factories, can be a windmill, can be basically anything. Measuring that, we've deployed a kind of 4 stages factor to that, and I'll describe that in some of the use case. And basically, that's what we consider to be the edge.
Okay. Teresa, how about yourself? I know you've done some things in oil and gas recently over the last couple of years. Tell us about your perspective.
Yeah, I think some of the definition is similar, but I think it takes a much more extreme case in upstream oil and gas. If you think about a rig, oil well, somewhere with there, AJ was there, right? So these places might not even have cellular or satellite connectivity. It's literally accessed over the air, where over the air might be a helicopter that flies out there, and when it gets out there, you're getting a physical access to the data, and you might make some physical adjustments to the running of that equipment at the edge before coming back. And so the operations and the analytics and the things that you deploy in that edge environment really need to be headless, meaning it needs to operate with very little connectivity to the central cloud, right, the centralized place, but yet with all the governance and with all the right permissions to do the things it needs to do on the edge.
Well, I have a question, because I saw in some of the panelists' definition of the edge, you actually talked about the plants and the buildings as the edge. And I'm not sure everybody shares that definition, so maybe you can illuminate one on why you think that's the case, and maybe if there's some differing viewpoints in that regard. Olivier?
Well, I think it all starts, as Teresa was saying, this notion that we do need a different paradigm for doing smartness outside the traditional, IT plays. So the way we look at it is, on one hand, the things that we need to measure, of course, all the sensors technology that goes to it, and then another stage is the whole data ingest and actuation. So the control piece is actually very important. Very often we think about edge as kind of the new big data things, but in a kind of a one-directional way. Like I collect data and I make smartness, but the control, the ability to actuate, to influence what I'm measuring is actually very important. And then the early analytics, the edge analytics, and then finally, the big data. So there is this compromise between instantaneity and kind of deep, more a batch kind of work. What we're doing is a very unique value proposition. Is we're bringing the level of compute that you find at the data center at the edge, the manageability that you find at the data center in the edge, and we're doing this IoT convergence. So we bring IT standard to the edge. That's the way we define the whole approach, yeah.
Okay. Well, great. Just to make sure we can get to the use cases, let's change it up a little bit. Maybe let's start with one of the use cases, and let's start with Russ. You want to talk a little bit about your use case, cover some of the business case involved, and the relevance of the edge to your case?
Sure. Yeah, so I'll cite a utility, a sort of family of use cases, if you will, and it all starts because of the proliferation of distributed energy resources. So things like photovoltaic, right, solar on the roof, wind, battery storage, home generation, whether it's gas or diesel fired. So what it's done is give rise to a whole set of use cases because utilities traditionally have not managed from the grid edge in, they've really managed top down. So they've invested a lot of money in the bulk energy transmission and distribution system where they have not invested nearly as much, and a lot of these smaller low voltage substations are not even instrumented or digitized today. So what you have is a case of complexity at the edge where people are generating through net metering, putting energy back on the grid, and the utility then has a hard time managing energy flow, over-under energy situations, and then having to manage those assets. Are they being pushed to their extreme? If there's a constraint regarding power at certain transmission, a certain transformer, who's going to mediate? Who's going to turn on their air conditioner? Who's going to plug in their EV to be recharged? So some of these things are good examples of where edge computing can make some of those decisions in mediating those types of transactions, whereas the utility certainly can't be involved in every one of those transactions, just physically, humanly impossible to do that. So we see that intelligence will be built into endpoints, whether it's smart meters, whether it's in distribution, low voltage distribution centers, pole top transformers, in order to make those kind of transactions happen in the future. So the benefit or the use case of that is going to be better utilization of assets, being able to anticipate if there's going to be a problem so that you can respond, right, with the right maintenance crews, and it's also trying to prevent those problems from ever happening. So that's really where we see some of these use cases happening in the utility industry at the edge of the grid.
Okay, great. Thanks, Russ. AJ?
Absolutely. So I'm going to bring this use case from connected city lighting, actually. This is a use case we actually implemented in Czech Republic, so pretty new there. It's part of our, as I said, IIOT programs there. So what we do, we actually have the street lights really kind of automating some of those adjustments in terms of the brightness, the remote lighting control, some of the fault tolerance that we build, even the anti-theft in the street lamps. It's part of our actually the whole smart city move from Huawei. So the main thing here, what we do, this lamp controller that is installed on every lamp post is actually has got the smarts and sort of the edge analytics built into it from the processing of the data. So it kind of talks to our controller through some of those protocols like NB-IoT. I don't know if you heard the name NB-IoT. Huawei has actually created that protocol and responsible for creating some of those NB-IoT chips. You can also use some of those Wi-Fi solutions like low power PW1. The whole idea really here is there is a two-level control here. If there is an upstream connectivity broken or you cannot connect to the upstream controller, the smartness built into the street lamp controller on the lamppost can still continue to function in terms of some of the light adjustment. The main idea really, if you look at the overall problem here, some of the research says there are like 304 million lamps around the world, and it's expected by 2020 that number is going to go up to 352 million. By doing some of these things that we are doing as part of our smart city and connected lighting solutions, imagine the amount of cost, that's the savings that's going to happen to the city and to the world as a whole. So we have some of these demos in our booth. Be happy to show you that use case as well from the connected light. There are many other things, but this is the one that stands out in terms of energy savings and utilities.
Let's move from the end of the hydrocarbon value chain all the way to the other extreme. So Teresa, why don't you tell us a little bit about upstream oil and gas?
Yeah, thanks. So I'll tell it in a way that might be more applicable for general use, right? So it's a brownfield example. So with oil and gas, like many of your business, they have been doing edge computing, edge analytics for decades, right? So in the way that I described with the helicopter going over to the site. And so these use cases like drilling, asset maintenance, cementing, these are things that they already have some analytics for. And so a brownfield use case is that right now these are all proprietary, where they have very custom hardware. Each service line across the business has their own hardware, their own way of doing models, the way of representing data. And one way is just that it's inefficient. Right, so the use case was made to do something around modernizing this. First step, we added a way of working based off of containers that takes these existing analytics applications and containerizes them in a centralized way that's governed. And then we can now push these to the edge in a way that is a consistent platform, but also has a path towards modernization. So we're starting with existing analytics, the existing applications, and the existing hardware. So a lot of these are ruggedized servers and ruggedized equipment. And you definitely want to do better, but because we're starting with this approach, now we're able to do a proof of value by just getting the existing use cases working. Now our service lines have a common platform to develop new stuff off of, and in a way that, because it's container-based, I can swap out technology as it becomes newer and take advantage of that.
Thanks, Teresa. Olivier?
Yeah, so I picked a use case in the utility world, very large energy company in the US. This is a program we're actually doing collaboration with a partner, National Instruments, and we're demonstrating the use case being condition monitoring at our booth, so I invite the audience to stop by. So you see here these 4 stages I was describing from the thing. So in this case, it's gas turbine, about 10,000 assets across 60 plants in the US. And basically, we're measuring vibration of those gas turbine with the objective to eliminate what's called false type 1 error, which is basically this scheduled maintenance where you may fix and spend money on assets that are working. So you're trying to avoid that and really looking at those that have problems. So we're comparing a digital signature of those gas turbine with a number of preset, a database of signature, and then we detect those assets that need fixing, and we avoid also dispatching field engineers unnecessarily. And of course, we're also fixing type 2 errors where we would save maintenance budget, do not touch an asset, and then it broke, right? So it illustrates a bit the architecture we're deploying, where we have sensors, we have data ingest and actuation components, and then this analytic piece that we're running at the edge, and finally doing the deep analysis, the deep learning in the data center. So this kind of 4 stages deployment.
A question for the panel. Where do you think we are in terms of overall adoption of One IoT? How important is Edge, and where are we in the adoption of Edge technology in some of your segments? Because I know we talked about some great use cases, but are we in the early days? Are you only seeing 1 or 2 kind of customers that are really leading the pack? Where are we today? Maybe Russ, can you start with that?
Yeah, I think in the utility industry, for example, we're at the very early stages, with the exception of smart meters, which is generally regarded as an IoT device because it's an endpoint device, and it's been fairly well deployed. About 60% in the US, at least, homes have smart meters, and here in Europe, they're following the same pattern or not far behind. But when it comes to just deploying inexpensive sensors, IoT devices, utilities traditionally have selected highly proprietary devices because they have to be highly secure, they have to work with SCADA, distribution management systems, so they really are very well engineered to meet that need. They're not used to putting in sensor devices, analyzers, that are just internet compatible or cellular devices. So I think we're at the very early stages, and most utilities that I know of, unless it has a head end to control it, they really haven't installed it. So the question is, how will they deal with a mixture of different types of devices, line sensors, fault sensors, analyzers, that they really can start to deploy, but I think at this point they don't even have a framework for how they're going to manage and control that. And because of NERC SIPs and the critical infrastructure protection requirements, they're very concerned about security, and they should be. They're very concerned about the reliability, the connectivity. Will they have it when they need it? And right now, their proprietary SCADA systems kind of serve that need. But I see that IoT is going to supplement that and give them information. So it's going to change it from a model-driven, connected model-driven type of device-centric operation of the grid to a data-driven model, because they're going to have so many more sources of data. That's how I see it going, but it's going to take a while to get there.
Thanks, Russ.
Yeah, I agree with that. I think what we see today, and even last year, we were taking more of a cloud and centralized view of the world where we brought the data to the cloud, and that's where analytics and these models happen. And at best, we might have pushed the results of the findings to the edge. Maybe it sets a set point or a threshold. But now what you're describing is what I also see as well, that we're not mature on this, is to actually, you're going to manage the population in the cloud, but then each device, you're going to push the analytics to the data, because that's where the high fidelity data is that you couldn't even pay to bring it all. Maybe probably would make a lot of money, but you can't bring it all to the cloud, right? So you have to push those models now to be self-learning at the data, and then everything is very contextualized at the thing, right? So it's pushing the analytics to the data.
Okay, great. Anyone want to add something here?
Now, I would say to bounce back, I think the reason of the edge compute, and to the question of why is it taking probably longer than we would expect, I think it starts to become a bit a common wisdom, as the poll we did at the beginning of the panel, that there is an absolute need for edge compute. I think it's IDC predicts like 40% of the compute will be at the edge, and we know security, we know bandwidth, we know latency, the whole real-time notion. I think what's probably preventing the adoption more widely is those silos coming from the operation technology. So one big thread is to bring the goodness of IT to the OT world. And that's what we're trying to do by standardization, using common platform, pushing these kind of IT standards, both security, management, to the OT world. But let's face it, OT, they've been doing the business for like 40 years, and they won't fix something that's working.
Yeah.
So that's why also I think it takes more time than we as technologists would like to. Yeah.
Sure.
So I'm just going to say, if you look at the edge computing, kind of start to compare it with where cloud computing was 5 years ago. Cloud computing became a mainstream, let's say, in 2014, 2015. So edge computing is going to be the sort of the next disruptive force. And the people are really grappling with some of the things like you said, Teresa, last time, that there are business models are changing, the revenue models are changing, and people are coming to terms how to monetize these things. Analytics is great, how to make sense of it. There are many challenges that are still in the way of edge computing. Mentioned about the latency, some of the real-time experience has to be less than 10 milliseconds, but the major problem is there's so much data that is created at the edge. If you look at it, a car that travels 1 mile creates like 10 gigabytes of data. How do you assimilate that data? The data presentation, the data unified presentation, the standards, the interoperability is still a major problem. And there is no standardized interfaces from an infrastructure point of view that I can tell you this is what everybody is going to adopt it. And obviously, security has been mentioned many times. And I'm just going to make one quick comment on the security here. On one side, security is supposed to be better because you're not going all the way to the cloud and you're just limited into your local LAN, basically. You're creating those geo-fences. But at the same time, look at those edge devices. They're much more vulnerable to the attacks here. I don't know how many of you remember there was a SYN flood attack called DIN, actually, a couple of years ago, using the video cameras because there was no access controls there. So those are the problems that people have to grapple with and come to terms before it becomes acceptable for massive adoption. Data privacy was mentioned. What happens to the General Data Protection Regulation in the EU, if I remember it right, which is going to be the law next year? So how do you deal with those privacy issues? So those are the things, challenges you need to answer before it gets kind of widely deployed.
Well, let's talk about the journey so far and the key takeaways, right? I'm sure we've all had our challenges trying to actually deploy IoT technologies get the industry to move forward to really deliver the great outcomes that we know are possible. So let's talk about the first, those key takeaways. Maybe Russ, can you start off?
Yeah, I think building on the point I made earlier, you have to get the utilities to get over the concerns about new devices and things that they're just not comfortable with. And what I'm seeing is that they're starting to put their toe in the water. They tend to want to bring all the data back rather than do it out in the field. Put it into a historian system, whether it's Pi or some other ones, and then of course it's sort of locked in there and almost never to be heard from again, unless you look, you take it out on a periodic basis and do some canned reports out of it. It's just not the kind of thing that will inform them on a near real-time basis. So what we're trying to do is get them comfortable with deploying some of this data. Clearly, price is always a consideration. And as these sensors are fairly inexpensive, they really can deploy a lot of them and get a big bang for the buck. So we are seeing that that's sort of the roadmap that they're taking. They'll take smaller steps in the beginning, and I think we want to be conservative in an industry that reliability is the coin of the realm. So that's the thing that we're encouraging, and from a pilot standpoint, we're trying to get them to understand how IoT can supplement and complement some of the systems that they're already very comfortable with, to give them a fuller picture, have more visibility into the state of their grid all over the place. If we're ever going to get to this so-called transactive grid, or having a collection of microgrids, literally thousands of nodes where transactions could take place between consumers, energy service providers, right, traders of all kinds, it can't be a centralized control system that the utility has to push the buttons and the levers. It's got to have to be distributed in how those transactions take place and are, in effect, recorded. And I haven't even talked about blockchain being part of this whole thing, and that's a whole separate area. But that's where I see things going.
Okay, great. Teresa, you get to represent oil and gas here, so tell us a little bit about the takeaways unique in oil and gas.
I think it comes to the end, same about the interoperability and the transactional grids in your case, but on the oil well, it's also an ecosystem, right? You have the well that's owned by a BP, a Shell. You have all your services like ABB, Schlumberger, Halliburton. Then you might have the utility company also part of that mix. It's about having that ecosystem to make sure the well is operating properly and doing the right thing and everyone's safe. Right, so how do you make that work together? So things like blockchain, things like governance, things like doing things at the edge in a way that everybody feels secure, is interoperable. I think that's the way. You can't control it in a centralized way anymore. It becomes much more of a collaborative, federated way.
Olivier?
Yeah, so to bounce back on what Teresa said and stay on oil and gas a second, I think the notion of trust and sandbox, giving a safe environment to try things, so it's very important, right, in this change management. So one thing we're doing, we're working near Houston with a petrochemical company called Texmark. And we basically, so they are doing like a chemical process transforming a byproduct of oil. But more importantly, we've defined a number of use cases whereby they create the sandbox for the Exxon of this world, who are a bit less agile to be able to experiment. So on one hand, it's kind of showcases, for example, preventing maintenance, looking at the whole process. They do something they call towing, so they lend their kitchen to other companies, and so defining and understanding precisely how that process transformation works for predictable outcome is very important. So they do it themselves, but also they provide it as a sandbox to an Exxon, a BP, a Shell. Video surveillance, avoiding leakage via video analytics is another use case. Mans down the whole safety approach. So I think walking the talk by providing those sandboxes is going to be a key enabler to increase number of projects and adoption.
Okay. AJ?
Sure. General takeaways. I'm just going to make an overall comment here. I mean, whether it's in oil and gas or in other industries, the edge computing is here to stay. It's not going anywhere. There have been lots of people who spell the doom of cloud computing. It's not going to happen, so they have to work collaboratively, edge and cloud together. One thing that's happening on the edge computing side, the edges are getting smarter and smarter. When I say that thing, you can see the battle that's happening, let's say, on the autonomous connected cars, et cetera, or some of the, your drones could be your edge, actually. So the point here is, let's get to some of those edge applications, the use cases mentioned here, see how it can apply to you, what use cases make sense to you, how you can best utilize in the years to come. I mean, the way they say it, for example, why you would still need a cloud computing at the same time as the edge computing, your smart edge, can actually, for example, can tell you, yeah, it rained yesterday or it's going to rain today, but it cannot tell you what's going to happen tomorrow. So the point here is you need the centralized model to do some of those big data analysis, but a lot of it can be migrated towards the edge, and edge can become a lot more intelligent, actually, in the years and days to come, actually.
Okay. Thank you. Let's take a couple questions from the audience. So if you'd like to step up to the mics and just announce your name, company, your affiliation, and ask your question, please. Any questions? Okay, well, I guess I can ask some questions, no problem. When we talk about suppliers, it's kind of interesting, right? You've got edge suppliers. I think we've got a couple of here that supply technology on the edge, enabling infrastructure. We've got other groups that actually maybe do full-scale systems integration. Obviously, we've got other suppliers who really focus on the cloud, provide enterprise-level solutions. What do you think the market thinks in terms of who's going to be the supplier here? Are they going to look for one supplier to provide an integrated system? Do you think it's going to stratify along the edge, and then the cloud providers, the solution providers? Because I think this is a fundamental issue that really is causing customers to really have a problem in terms of who do I go to in terms of supplying me the underlying enablement to deliver these value propositions? So who wants to take that question?
So maybe I can start. I think there is not one company that can do it all. I think we see it, at least it's our experience, this notion of consortium is even more important in the IoT. I mean, the number of players to build a solution is just 10x what we see in traditional IT projects. So I think the reality is that we will have multi-form engagements, and building the trust between companies, defining the role and responsibilities, the governance is critical.
I think that Teresa brought up a good word, interoperability. It's a mouthful, but really what it means is that do these devices, do they work together, right? It's kind of that simple. So what we've done is we've tried to, we build ecosystems around different technologies, just like, Wintel did it for the computer, the desktop. I think you still see those kinds of things forming. So, we've done some things with Intel, where basically you build, everything that works with the Intel chipsets, the security is built in, as well as the operability, and you see that kind of consistency throughout. You also have standards being built too, right? So in the utility business, there's the IEC standards that we're all looking to conform to. You've kind of got a standard built canonical model when it comes to IT. So I think we're trying to build systems that work in that, so at least everybody can participate, and we're not shutting people out of that ecosystem. We're just trying to be inclusive and also set up the standards so that things can interoperate.
Yeah, and I think it's actually a great opportunity because in that standardization, you can have specialization. Maybe you might specialize as the best device manufacturer or as the best device manufacturer for oil rig, right? Or the best model creator for that type of data, or I might monetize my data. So the standards actually are really great because it introduces a new opportunity for these new businesses to come that specialize on just one part of that.
Totally agree with the rest of the panel here. It's going to be an ecosystem. It's going to be people specializing in part of it. Actually, like even in our use cases, we lent our expertise on the chips and networking to that smart controller that's posted on the lamp here. So there is going to be new opportunities for monetizing these things. So I think No single vendor, and once you deal with some of those interoperability and standards challenges, no single vendor can do it. It's going to be a complete ecosystem of partners really coming to the rescue of edge computing.
Okay, great. Well, I think we're still early in the journey. I myself, being in oil and gas and energy for a long while, I think we definitely see the need for it. And there's really, I think, a lot of capabilities going to be enabled by edge compute. So I think we're in the very early stages, but I think it's what we find from this panel is that we need to start thinking about the strategy of the edge, what the actual business cases are, and get started, but find to do that in a way that's actually secure and actually allows you to evaluate new business models and opportunities due to edge computing. Well, thank you, panelists.
Thank you.
And thank you for, there's looks like a question.
No.
Okay. Go ahead.
Yeah, excuse me.
Hi, everybody. I'm an example of an edge vendor, so we provide edge fog software, so we believe in that, of course. I was also going to ask, or thinking to ask about, is it a one-stop shop, or how do you pick the pieces and so on? But good that you asked that. One comment to all this about how edge is going to pick up. Often we talk to customers, they don't really know what edge is. They don't even know what IoT is, but they have projects. So it's also a question of education. When we talk to, okay, do you have an IoT project? No. All right, but do you want to do something with the data out there, the sensors, and connect that, and maybe to the OT part? Yeah, we do that. So there are projects, there are needs, but it's also a question of education and terminology. So just wanted to see if you had the same experience out there. Thank you.
Thank you.
Yeah, no, I would totally agree. I think we didn't talk too much about change management, which is a huge piece of adopting those new technology. I think within change management, there is communication and branding internally those companies that are doing those early changes. I think that's very, very critical, and it's part of the journey, right? Making clear use case, short returns, and then communicating internally, very important.
Well, thank the panelists. Oh, okay, now we're getting questions. Here we go.
Yeah, sorry. My name is Fabio Bottacci. I'm the founder and CEO of Vinci Digital. I'm industrial IoT advisory in Brazil, actually. I'm facing a lot of problems as our colleague in terms of knowledge, basic knowledge of what it is, okay? So as an ex-oil and gas executive and now playing in this innovating field, the problem is that big corporations usually don't have the startup, agile mind to try and allow to make mistakes. So I always have to refer what I did as an executive as not only proof of concept, but a compelling business case to present to the board, specifically for a pilot, and then showing some numbers, giving the number, bottom lines, results, and then eventually scale. But you can imagine if we are starting at a position that nobody knows what's IoT, and then we go to the edge computing, and then we go to prescriptive analytics in mission critical power station or whatever, with machine learning algorithms, deep neural network. I mean, this is, for me, the biggest challenge is a mindset, cultural shift, and the mindset of what I was 3 years ago, just an industrial executive in the oil and gas sector. So how do you guys struggle? What's your magic formula to do that?
Okay, who's got the magic formula? Anybody?
I didn't, because I did the brownfield example.
Okay.
So that was easy because you could just take things that they're doing and it becomes an efficiency story. And that by doing that, now they feel more comfortable, and yet the term edge is sexy. So they're both doing something sexy, but you have a proof right there in terms of efficiency. And then now you have a great foundation on which to do more easily do new POCs and introduce that into the story.
Yeah, I will say there's clear use cases that the oil and gas operators are seeing that actually they know they need good edge capability. If I'm just looking at security on a pipeline, theft on pipelines, for example, but I think it's about actually being able to talk about those use cases and make that business case and actually frame some kind of small pilot that's actually easy to show business results. So I think that's a common pattern across many of the industries, but you actually have to be able to, unfortunately, talk to them about an operational challenge or business issue that they have and talk to the right stakeholders as well.
Yeah, if I can add, it's not only an operational, it's a completely new business model. Sure. We got a shift from product as a service. I mean, we got GE doing that with digital turbines. They are not selling anymore, they are just renting and selling maintenance and everything. So.
Well, I'm sure that our panel would love to share their perspectives, show the demos that they have on the edge, and be able to help you through that journey. So I welcome you to definitely go to the booths, talk to our esteemed panelists, and thank you for your time.
Thank you.
And thank you for the discussion.
Thank you.